Hello and welcome back to this channel, and today we are going to discuss this thing but this thing only you can understand if you have completed your hydrocarbon chapter. If you have completed your hydrocarbon chapter, then only you can understand this thing. And I hope you have done this. We have already discussed hydrocarbon chapter in detail, okay? I have taught you all these things, all the concept and all this. So this question is called roadmap questions. These are called roadmap questions. Like, this is not the name of this. Like, we can call it roadmap question, like where one or two of these molecules will be given to you and so many reagents are given to you, and you have to combine them and you have to understand that what is the product you are getting. You see, here total 16 products. Oh my god, 16 product I have to do. Okay, so one by one all the reactions we'll understand, and it's super easy, it will be super fun and you will enjoy it. Okay, you see, first thing is given is calcium carbide. Calcium carbide is reacting with H plus H2. So sir, what will happen? Okay, so let's go to the next page. Calcium carbide, we have already done this, right? Calcium carbide, what is the formula? I told you that it looks like this, C minus, and as it is having 2 minus charge, so to balance this there is a positive charge also. Okay, if you are reacting this with H plus H2O, sir, what will happen? Nothing much will happen. This negative will take this H plus and this negative will take another H plus. So if that is the case, sir, I will get HC triple bond CH. What is the name of this? Ethine. Very good. But I told you to remember the common name of this also, that is called acetylene. It is called acetylene. Okay. Now this is your product number A. This is your product number A. Now you see, from A, Fe tube and 600 degree. Okay, sir, that also I know. If from here, if they have used Fe tube, or when I taught you, I have told you that you should write it as red hot Fe tube, right? At 600 degrees centigrade. So what happens? 3 of this acetylene you have to take and you have to do polymerization reaction. 3 of this you have to take, you will do polymerization reaction. What will happen, sir? Write the molecules like this way. Write the molecules like this way. Write the molecules like this way. Add this, add this, add this, and sir, I got it. You want benzene ring. Yes, I want benzene ring. That will be your product. That will be your product. So sir, that means this is 12. This is 12 and this is a benzene ring I am getting. So 12 is done. Now from here, NaNH2 is given. Sir, NaNH2 means it's a base. It's a base. So from NaNH2 if is given, NaNH2 means Na plus NH2 minus. Let me change the color, NH2 minus. Now this acts as a base. And I told you that this hydrogen is called acidic proton because that is bonded to a sp hybridized carbon atom. All this percentage of S character and all this I have discussed in detail, right? This NH2 minus will take this hydrogen and you will get the negative charge here. So sir, I will get this HC triple bond C minus Na plus. This I will get. Okay. And this will be your 2. This will be your 2. Now this is reacted with CH3I. Sir, this negative charge can attack this carbon and I as a leaving group, it can leave. So if this is the case, then you will get HC triple bond CCH3. That means this is called propyne. Propyne, and this is your 3. This is your 3. Okay. Then if that propyne, okay, that propyne is taken in Fe copper tube. It is reacted with red hot iron tube or copper 2. Sir, what will happen? Now again you need these 3 molecules, but now how to orient this? You can orient this like this way. C triple bond CH with a methyl group. Then C triple bond CH with a methyl group and C triple bond CH with a methyl group. Then add it. Okay, sir, I understand that I will get a benzene ring with a methyl group here, a methyl group here, and a methyl group here. Sir, how do you know that I will get a methyl group here? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You see, carbon number 1 is having a methyl, carbon number 3 is having a methyl, carbon number 5 is having a methyl. So this is your structure. Sir, what is the name of this? 1, 3, 5 trimethyl benzene, or this molecule is known as mesitylene also. Mesitylene. I hope I am like spelling it correct. Mesitylene. Okay. And this is your molecule number 11. This is your molecule number 11. Okay. Now go to the next slide. What is given here? Okay. Now from 1, they have given NaNH to excess. Sir, 1 is this one, right? 1 is acetylene, right? Yes. So you take acetylene again. Now NaNH2 is given in excess quantity. NaNH2 is given in excess quantity. Sir, what is the meaning of this? That means this NH2 minus can take this hydrogen. Okay, let me write it in this way. Let me write it in this way. C with hydrogen and C with hydrogen. And this bond goes, and sir, as it is given in excess amount, so I can react this way also. Okay, sir, that means I will get C triple bond C minus, I will get Na plus here, and I will get Na plus here. As NaNH2 is given in excess, so both the side it can react. Okay, sir, I understand. Then it is my 13. It is my 13. Okay. Then, sir, with that 13, what is happening? CH3I in excess. Sir, I understand what you are trying to do. Both the side you want to do the reaction, right? Yes, very good. So CH3I will attack here and it will attack. That means you will get CH3, C triple bond C, CH3. That means but 2 ion as your product. You see, the same reactions we have done here also, but here only one side. Here and here only one side I have done. And now we are doing on both the sides. Sir, why? How to know that when I have to do the reaction on both the side or on the one side only? That depends upon this excess factor. That depends upon the excess factor. If it is given in excess quantity, then both the side you have to react, right? Both the side you have to react and you will get your product as but 2 ion. Then what is this molecule? I guess this is your molecule number 14. But sir, from molecule number 14, there are 2 reactions they are doing. Oh my God, so many reactions. Yes. One is H2 PDC, another is sodium liquid ammonia. Okay, sir, you cannot trick us because we have done this so many times. This H2 PDC is called Lindlar catalyst. This is called Lindlar catalyst. If it is Lindlar catalyst, and sodium liquid ammonia is called Birch reduction. This is called Birch reduction. This is Birch reduction. So Lindlar catalyst means from triple bond I will get cis to butene. Lindlar means the product will be cis. Birch means the product will be trans. So this means you are talking about this I will get. Yes. First of all, hydrogen will be added. Here hydrogen will be added in the cis fashion. You see, both this hydrogen and this hydrogen, they have added from one side. Both the hydrogens are on the one side of the double bond. That is called cis to butene. This is cis to butene. Sir, what about this? Here, you will get the double bond. You are giving a CH3 here, a CH3 here. H here and H here. Sir, that means you are talking about we will get trans 2-butene, right? Yes, you will get cis 2-butene and you will get trans 2-butene here. Okay, now let's name them. So one is 15, another one is 16. So this is 15 and this is your 16. Got it? 15 and 16. Okay, sir, all are almost done. Yes. Now, what is your 3? Let's check what is your 3. 3 is then this molecule is my 3. This molecule is my 3. Okay, write it. Freshly write it. CH3, C, double bond, CH, right? Double bond or triple bond, let me just check. I think it's triple bond. Yes, triple bond. Okay, sir. That means that it was propiene. That was my compound number 3. Sir, what I have to do? 3, you have to react with H2PD. H2PD means that I can do a single step of reduction. I can do a single step of reduction. And if I do, I'll get CH3, CH, double bond, CH2. It was the alkyne. If I reduce, I'll get alkene. But sir, from here, so many reactions, 5 reactions are going on. Okay, no problem. We will do one by one. So the first reaction is, it is treated with HBr. Sir, HBr addition, we have done this, right? Yes, HBr addition means we can follow Markovnikov rule, or otherwise we can understand the stability of carbocation and all this. So here, there is no exception, so you can use Markovnikov rule. So this is the negative part, right? This is the negative part. So Markovnikov is saying that the negative part will be bonded to the carbon. Which carbon? Which carbon is my point of interest now? This carbon and this carbon is my point of interest because they are double bonded. So in between these two carbon, which carbon will take the bromine? Markovnikov is saying that the negative part will be bonded to the carbon having less number of hydrogen. Said less number of hydrogen means this carbon is having 1 hydrogen, right? And this carbon is having 2 hydrogen. So who is having less? Said this carbon is having less number of hydrogen and bromine will be added here. Okay? That is Markovnikov rule. Okay. That if this is the case, then I will get the product like this. I will open up the bond. This bond is open and this bond is open. I will add bromine here. I will add hydrogen here. Already these things have been discussed in details. I hope you know. If you are not, please let me know. Okay. Then this CH2H, I can write it like this way. No problem with that. I can write this like CH3, CH, we are CH3. Sir, what is the name of this? 2-bromo propane. Sir, what you have done? I have done Markovnikov rule. Okay, sir, I understand. But sir, what about HBr and H2O2? There is an exception, right? We cannot call it an exception. But here I have told you that in presence of peroxide, this is called peroxide. In presence of peroxide, HBr shows anti-Markovnikov rule. But here I have given you a note that only and only HBr in presence of peroxide, shows anti-Markovnikov addition. Only HBr, not HCl, not HI, not water, anyone. Only HBr, this is the note. Okay, sir, HBr is given. So no problem, we can do anti-Markovnikov. Sir, anti-Markovnikov means you are saying CH3, CH, CH2, I have to open the bond. Now bromine will be added to the carbon having more number of hydrogen. So this carbon is having more number of hydrogen. Bromine add here, automatically add hydrogen here. That means I can write this like this way. This is CH2, we are 1, 2, 3. This is 1 bromo propane. Okay, so we have done this. That means 5 and 6 are already done. This is your 5 and this is your 6. Let's go to the next slide. Okay, what is given here? HCl and HBr. Okay. Now, if I take this CH3, CH double bond CH2, and if I react this with HCl, sir, I know all these things. We have done this. This is the negative part. This will be added to the carbon having less number of hydrogen atom. It's a Markovnikov thing. Nothing to be discussed here. So you will get this molecule 2-chloropropane. 2-chloropropane you will get. Now, sir, if I react this with HCl and H2O2, sir, we know all these things, sir. I have identified Markovnikov, H2O2, so it will be anti-Markovnikov, right? No, it will not be anti-Markovnikov, because for having anti-Markovnikov, you need this combination. For having anti-Markovnikov, you need this combination is only for anti-Markovnikov addition. You need this combination H2O2 and HBr. You need this combination. If this combination is present, then only anti-Markovnikov. Other than that, with HCl also, if you do H2O2, you will not get anti-Markovnikov. Always you will get Markovnikov only. So, okay, sir, now it's clear that only if HBr is given, then only I have to do anti-Markovnikov, right? Yes. Only if HBr is given, then only you have to do anti-Markovnikov. Otherwise, always do Markovnikov. Then, sir, here also I will get the same product. That means 2-chloropropane. I will get. Yes, you will get 2-chloropropane. That means, sir, 7, 8 is also done. 7 and 8 is also done. Now we are left with ozonolysis. Okay, sir, ozonolysis also we can do. No problem with that. Ozonolysis also we can do. I can write the molecule like this. And if I do ozonolysis on this, ozonolysis O3 is ZnH2O. This is called reductive ozonolysis. And if I do the reductive ozonolysis, what you have to do? You just break the bond from the middle part. Okay? Again, what you have to do? Break the bond from the middle part. Sir, if I break the bond from the middle part, then, sir, some problems are arising. Yes. Now this carbon, okay, let me change the color. This carbon is having a CH3 group here and a H group here, and this carbon is having a hydrogen here and a hydrogen here, but they are in so much pain. They are suffering. Why? Because you have broken their bond. If you have broken their bond, then it's your job to satisfy the tetravalency again. How you can do it? You have to add double bond O. Satisfy the tetravalency with double bond O. These two are the product you will get. Okay, sir, if this is the thing, then this molecule I can write as CH3C double bond OH. This molecule I can write HC double bond OH. Sir, it's the aldehyde with 2 carbon. So the name of this is ethanol. It's a aldehyde with 1 carbon. The name of this is methanol. But I told you that you have to understand the common name of this also. Ethanol, the common name is acetaldehyde. In class 12, you need this. Very important. Methanol, what is the common name? The common name is formaldehyde. Okay? Formaldehyde. Okay. So these are your... just let me go top. 9 plus 10. Yes. So this is your 9 and this is your 10. I guess our job is done. Ozonolysis we have done, right? So, okay. Let's then do it clearly. Okay, then do it clearly. So your one will be a benzene ring. One will be a it's my fault. One will be ethine. Ethine, that means acetylene, right? Okay. 2 will be HC triple bond C minus Na plus. C will be HC triple bond C CH3. And 11 will be benzene ring with a methyl group here, a methyl group here, a methyl group here. That is called mesitylene or 1,3,5 trimethyl benzene. 1 to this will be a benzene ring polymerization reaction. 1 to 3, where you are using excess, it will be C triple bond C minus minus Na plus Na plus. If you react this with CH3I, your 14 should be both the side, you will have the methyl groups now like this. From here, if you do, it will be Lindlar, and if you do Lindlar, you will get CH3CH double bond C CH3H cis 2-butyl. This is Birch, and if you do Birch reduction, it will be C double bond C CH3H here H and CH3. Okay. If you do H2PD, your 4 will be a double bond, triple bond, and you will reduce it to double bond. If you do HBr, it will be Markovnikov rule. If you do HBr H2O2, it will be anti-Markovnikov rule. If you do HCl, it will be Markovnikov rule. If you do this is HCl, this has to be HCl, okay? Yes. HCl H2O2. HCl H2O2. If you do HCl H2O2, again this will be Markovnikov. It will not be anti-Markovnikov. Anti-Markovnikov is only when you are having this combination. So if I do ozonolysis, I will get CH3C double bond OH plus HC double bond OH. And in one question, 80% of this chapter is done. 80% of this chapter is done. So by this way, you have to do this type of questions. Okay, it's very easy. You see, with this one question, all the things have been revised. Okay, please try to do it by yourself, and we will meet in the next video. Until then, it's bye. Thank you.